Hello everyone, welcome back to part 2 of our series week. So the other day we talked about arithmetic series. Today we're going to be talking about geometric series. And so the series is the name for the sum of the terms in a sequence. So again, today we're going to be adding pieces together to make the series. And so a geometric series is the sum of terms that are from it really should be a geometric sequence. So geometric sequence is when you multiplied the same thing over and over again. And so today we are going to take those terms, add them together to make a series. So the sum of a finite geometric series. So this is where it has a firm starting and stopping place. This is going to be the formula that we are going to use. Now it looks kind of a lot. It's not as bad, I promise. So it says where a sub 1 is the first term. Just like in every other time, A stands for term, and that's the number. So term 1. R is going to stand for the common ratio. So the thing that's being multiplied over and over again, that's going to be our R. N is going to be the number of terms. So since there's a beginning and an ending point, there's going to be a specific number of terms, and that's going to be our N. And so then Sn is going to represent the sum of that number of terms. So if I chose 10 terms, this would be S sub 10. All right, so we have two examples here that we are going to use this wonderful formula to solve. So if we're looking at this, it says, example 1, identify A1, R, and N to evaluate this series. So let's first start by identifying those. A1 is our first term. Our first term is negative 45. The next thing is our R value. And so to find the R value, you take the second term and divide it by the first. So we're going to have 135 divided by negative 45. And 135 divided by negative 45 equals negative 3. And then the third thing we have to find is our N, which is our number of terms. So we have 1, 2, 3, 4, 5 terms. So N in this case is going to be 5. And the formula we're going to use is the one from above, but I'm just going to rewrite it here just so it's closer for us. So we have the sum, all right, of, in this case, we have 5 terms, so it's going to be S sub 5 equals, we still have A1, parentheses, 1 minus R. We said that N was 5, so we could put 5 there, over 1 minus R. So we have a couple more things left that we're going to plug in, and I'm just going to do that above right here. So we still have S sub 5. Our A1 in this case, we said it was negative 45. 1 minus our R value was negative 3. And we still have to the 5th power all over 1 minus R. So 1 minus our R was negative 3. So now we just have to continue on and simplify this out. So we're going to have S5 equals negative 45, 1 minus negative 243, all over 4. All right, and so then we have S sub 5 equals negative 45. 1 minus 243 is going to be 244. All over 4. And I think we are all very, very capable of typing in negative 45 times 244 divided by 4 in our calculator. So the sum of these first 5 terms is going to be negative 2,745. And so in this case, this is the formula. Maybe 5 terms you could just add in your calculator easier, but if I were to ask for 10 or 15 or however many terms, you're going to want the formula because it'll make it easier. All right, so we're going to do one more together. And so in this case, we got to start by identifying A1, R, and N. So our A1 is our first term. So in this case, it's going to be 1/3. We got to find our R value. And so you take the second term and divide it by the first. So we have 1/9 divided by 1/3. And so this is really equal to 1/9 times 3/1. So whenever you have two fractions that you're dividing, you take the reciprocal of the second one. And so then this is equal to 3/9, which is also equal to 1/3. So our ratio, our common ratio in this case is 1/3. And the last thing we have to find is our N value. And that's our number of terms. So we have to count them up. So we have 1, 2, 3, 4 terms. So our N is going to be 4. All right, so now that we've identified our 3 pieces, we have to plug them in to the formula. So we have the sum of 4 terms equals A sub 1, parentheses 1 minus R. Our N is 4 over 1 minus R. So we're going to take and we're going to plug a few more things in. So we're going to have S sub 4 equals, our A1 in this case is 1/3 times 1 minus, our R is 1/3 to the 4th power, all over 1 minus our R again, which is 1/3. So we're going to take this and I'm going to kind of just like bring it up over here. So now we have S sub 4 equals still our 1/3. We're going to kind of simplify this right here. And so 1/3 to the 4th power is going to be 1 minus 1 over 81. And then 1 minus 1/3 is 2/3. So we're just going to keep on simplifying this. And so S to the 4th power is going to equal 1/3. 1 minus 181 is just going to be 80 over 81 over 2/3. All right, and so then we have 1/3 times 80 over 81, which is going to be 80 over 243 divided by 2/3. And so at this point, you could type in your calculator. You could have at earlier points too, but so 80 over 243 divided by 2/3 equals 40 over 81. Or you can turn it into a decimal. It doesn't really matter to me. All right, but so you have to identify A1, R, and N. A1 is your first term, R is the first 2 divided, and N is the number of terms. Plug it into the formula and kind of simplify it out. All right, don't let the fractions scare you. Just work through it. All right, there's one more thing that we're going to cover, and so that's determining if it diverges or converges. So converges means come together, diverges means go apart. And so looking at this, it converges when R is less than 1. All right, so it's converging when it's less than 1. And so you can find the sum. So when it's converging, you can find the sum. All right, whereas if it's diverging, there is no infinite sum. So if it is greater than 1, that means it diverges and you can find no infinite sum. It's not possible. So all we're going to do for this last example 3 and 4 right here is we're going to decide whether it diverges or converges and state if we can have a sum or not. So we got to find our R value. When finding an R value, you got to divide the first 2 terms. So R equals, we're going to do 4 over 9 divided by 2/3. We're dividing the first 2, when you divide fractions, this is going to be equal to 4/9 times 3/2. You flip the second fraction. So we multiply across, so then we have 12/18. And so this is our R value. If you reduce that down more, that's wonderful. If not, that's fine. All we have to really realize here is this greater than 1 or less than 1? 12/18 is less than 1. And since this is less than 1, if we go up here, it means it converges and you can find a sum. So converges, has a sum. So if it's less than 1, that means it converges and you can have a sum. So if we look at our next one, we got to find our R value again. And you take your second one and divide by your first. So 6 divided by 2. And 6 divided by 2 is 3. 3 is obviously bigger than 1. And since it's bigger than 1, that means it diverges and has no sum. Because it's diverging, there's no way to find an infinite sum for this. All right, so we're going to flip it over to the next page. There's one last problem we're going to do. And just a little refresher at the top. So it says, you blank the sum if it's diverging. Diverging, no sum. So we cannot find the sum of an infinite geometric series. Not going to happen. But if it's converging, you can find the sum. So if it's converging, if it's less than 1, we're going to find the sum. And if that's the case, look at this little simple formula right here. Way easier than the first one. So if it's infinite, if it goes on forever and ever, we got our dot, dot, dots. We are in business, easy formula, loving life. All right, but first we got to look at this formula and identify what some of these things mean. So in this case, A1 is always the first term. R stands for the common ratio. And S is the sum of infinite series. So then the S stands for just the sum if we were to continue this on forever and ever. So we're looking at this. We got to identify two numbers. We got to identify our A1 and our R. So A1 is the first term. That's just 7. And we got to find our R. So you got to take the first two and divide them. So we have -7/2 divided by 7. And so this is equal to -7/2 times 1/7, because we got to flip the bottom. This is equal to -7/14, which is also just equal to -1/2. So our R value is -1/2. So we have our A1 and our R. We're just going to plug it right on in here. So S equals A1 over 1 minus R. Our A1 is 7. So our sum equals 7 over 1 minus our R value is -1/2. So we're going to simplify our denominator. So our sum equals 7 over, this turns into 1 plus 1/2. So this is equal to 7 over 3/2. And so right here, you can type this in your calculator if you want. That's fine. Or we can keep doing it algebraically. And so this is equal to 7 times 2/3, which is equal to 14 over 3. And so 14 divided by 3 equals 4.6 repeating. So either of those answers are completely fine. So if you're talking about a geometric series that is infinite, it has the dot, 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 this is the formula you use right here. You have to identify your A1, your first term, your ratio, where you divide the first two, and then you just take it and plug it in. I know that we talked about a couple different formulas here, so if you have any questions, please send me an email, reach out to Google Voice. I want to do whatever I can to help you, but I hope you are having a wonderful day.